Let's take a look at some examples of some properties that we'd like to be able to use with definite integrals. So this first property, the integral that goes from a to a of f of x dx. So what this means is that our width, we start at a, we end at a, but we still have some function. What is the area that we would expect that to be? Well, the area is 0, right? There's nothing there. We basically have the same starting point as any point. There's no area. Next one, if I have the integral from a to b of f of x dx, if I switch these, if I instead want to go from b to a, so if I go from left to right, a to b, that area, or that net area, is going to be negative if I go in the opposite direction. Okay, so you flip the upper and lower limits, then you just put a negative there. If I take the integral from a to c, I could separate this into two different integrals for my function. So if I want to separate this into two of them, I can separate it based off of the endpoints. So I could go from, say, a to b, and then from b to c. So if we think about this function, that if you're looking at this thing from a to c, you have this area here. This total area could be seen as the same as taking the area from a to b and adding on the area from b to c. So we're allowed to do that, or vice versa. If I find the area from a to b and the area from b to c, that will be the same as the area from a to c if I add those together. Next one, if I have a constant times my function, so if I multiply my function by constant, what can I do with this k? Well, we've seen it a bajillion times now. We can pull that out. K integral from a to b f of x dx. So you're allowed to pull out constants outside of your integrals. If I have plus or minus on the inside, again, we've seen this a lot. This allows me to separate this into two. Integral from a to b of f of x dx, plus or minus the integral from a to b g of x dx. So I can separate the inside of an integral into two different integrals if they're being added or subtracted. But again, not multiplied and divide, only added and subtracted. If my function is always positive or not negative, greater than or equal to 0, then this area, we just talked about this. This is always going to be greater than or equal to 0. If this was always less than or equal to 0, then the area is going to be less than or equal to 0. And if it's not, if it changes, then we don't know. It's going to be some type of net area. And this last one here that says that if f of x is less than or equal to g of x, then taking the area of f of x from a to b is going to be less than the area from a to b of g of x, which that makes sense. Hopefully, if we think about, say, with positive functions, if this is my f of x and this is my g of x, and I'm defining the area from a to b, this piece here is the integral from a to b of f of x. That's this area. The area for g of x, instead, is all of this. So, obviously, the area of the bigger one is bigger than the area of the smaller one. So, just a few properties. We'll go through some examples in the next video of how can we use these to do anything with our definite integrals.